Hello, everyone. Okay, hello, everyone. In this video, we are going to look at how to do divisions with decimal with some applications. And these are our learning objectives, 6 of those. Let's do it one by one. First, how do we divide two decimal numbers? Our first example, actually 2 of them, and we have a divisor as a whole number. We could have dividend. The first one is a decimal, but the second one is whole number. Let's see how to do this. Certainly, we can use a calculator, but now let's look at how to do it by hand first. So we put 9 inside this division symbol and this divisor outside. Now we ask this question: how many tools in 9? How many whole tools in 9? There are 4 of those because 5 will be more than 9. So put 4 up here. Then you multiply this together. 2 times 4 is 8. Put it underneath this digit, and then do a subtraction to get remainder. So which is 1. Since we don't have any more digits, this is where you put decimal point. Then you add zeros after that. So now you put the 0 down as if it's a whole number. So how many tools in 10? There are 5 tools in 10. Put 5 in here. So 2 times 5 is 10. Now there's no remainder. We divide it evenly. That means there's no more digits. So 4.5. The answer is 4.5. So what's the meaning of this 4.5? And there's 2 different meanings actually, depending on how the circumstances. But there are 2 basic meanings in division. First meaning is that you divide the first number into this many equal parts. This is how much in each part. So you divide 9 into 2 equal parts. Each part is 4.5. This is one way to interpret it. For example, if you share $9 into between 2 people, each one get $4.50. Second meaning is that how many second number is contained in the first number. 9 divided by 2 equal to 4.5, which means there are 4.5 tools in 9. If you use 10 divided by 2, you get 5. What this means? It means there are 5 tools in 10. It just happened to be decimal. There are 4.5 tools in 9. So let's do the second one. 3.2 is first number. We put it inside this symbol and divisor outside. Then we look at this one. We have 2 decimal digits. So in general, we say we have multi-digit numbers. When you have multi-digit numbers to do division, you divide this number digit by digit. In other words, we look at this number digit by digits to say how many of the divisor in each of the digit. Is there 3 in 3? Yes, we have 1 3 in 3. That's why I put 1 up here. Then 1 times 3 is 3. Remainder is 0. When you remainder 0, you don't write it. Okay, you just put this digit down here if you have more digits. So this is the decimal point. There are 2. And how many 3's in 2? We don't have 3 in 2. So we have 0, 3 in 2. So 0 times 3 is 0. Remainder is 2. Now add 1 more 0 and put it down here. That's 20. How many 3's in 20? 6, right? 7 will be 21. 6 is 18. Now remainder is 2. Now at this point, you can see this remainder 2, the result you get 6. The remainder 2, you get another 6. If you don't see that, just keep doing that. You add it because this is 2. There's now 3 in 2 remainder, right? We have no more digits. We need to add 0. So put it in here. And 6, 18, and 2, the rest are 6. So the result is 1.0665. How do you write that in an accurate way? You put a bar on the top of digits with repeating without rounding. unless we are required to round it to certain places and we round it. Otherwise, we can put a bar on the top of digit who is repeating. Now, here is your exercise here. All of the answers to the exercise questions will be below the video in the comment area. Now, let's look at another example. In this example, notice that our divisor is a decimal. How do we divide decimal number without using calculator? First, we want to convert the decimal number to a whole number by moving decimal digit to the right. Apparently, we have to move 2 digits to the right. When you do that, you make this number 100 times bigger because you move 2 digits. Each digit represents 10 times. You have to do the same thing to the first number to keep the result unchanged. Okay, so 2410 divided by 4. These two are equivalent. Now we can just do this division. 2410 divided by 4. Again, we look at this number digit by digit. Is there a 4 in 2? No. That's why there's nothing up here above 2 because there's no 4 in 2. Move 1 digit to the left, to the right. I mean, how many 4s in 24? That's 6. That's why you put 6 up here. 4 times 6, 24. Remainder 0. Again, you don't need to write 0. Remainder is put it down 1 digit. This is a crucial part. Okay, you put down the digit 1 by 1. Ask yourself, is there 4 in 1? There's no 4 in 1. There's 0 4 in 1. They put 0 here. If we have 0, we don't put 0 because there's no point to put 0 in front of a whole number unless it's a decimal number. You put 0 point something. Okay. Now we put down 1 more digit. Sure, this time we have 4 in 10. There are 2 4s in 10. That's 8. Remainder is 2. And again, there's no more digit. We need to add digits. Since this is a whole number, we add digits. The whole number has hidden decimal point at the end. Okay, this decimal point. Add 0, put 0 down here. How many 4s in 20? There are 5 4s in 20. Divided evenly now. So answer is 602.5. That's our final answer. Now let's verify it using the calculator. 24.1 divided by 0.04 equals 602.5. Say 602.5. That means there are 602.5 0.04 in this. Now, let's look at our next topic. We're going to write a fraction or a mixed number into a decimal number. And let's go straight to this example. Everybody can read, right? Now we want to convert this fraction, it's a pure fraction. We don't have a whole number part. And we write this fraction as a decimal number. In the fraction, this bar, sure, it is called a fraction bar, but there is another name. And the other name is division bar. So we are going to do division. 5 divided by 8. That's the meaning of this bar. Let's see what we get. We should get something like 0.625. Yeah, 0.625. It makes sense, right? If 4 divided by 8, 4/8 is half. This is a little bit more than half, say more than 0.5. Makes sense. At the same time, it's smaller than 1. 8 over 8 is 1. This is smaller than 1, right? So it makes sense. Now you have your exercise problems, 2 of those. Now move on to the next page. Now we're going to convert this negative mixed number into a decimal. So this negative sign is for the whole thing, okay? It's not just for 17. So when we convert a mixed number into decimal, all we need is convert the fractional part into decimal part. We don't need to work with this 17 because we know 17 to 11th must be between 17 and 18. That's for sure. That means you're going to get 17 point something as a decimal. That's why we don't need to touch 17. So this is going to be negative 17 point something. That something is 2 divided by 11. So 2 divided by 11. 181818. So 181818 and so on. So you can see 2 digits repeating. So we're going to write it. I mean, negative 17.18. This both digits repeat itself. That's why we put the bar to cover both digits, unless we are required to round it to a certain place, right? Now, next topic, evaluate square root. So what does the square root mean? For example, 16. This operation tells us you need to find a number, one multiplied by itself. The result is a number inside. Certainly that's 4, right? 4 times 4 is 16. That's the meaning of square root. But sometimes when we have number that is not perfect square of another number, you will get a decimal. That's why we need to use a calculator. That's why it says approximate, because you're going to have countless digits. You have to round it. When you round it, you don't get exact number. That's why they say approximate. Now let's use this the calculator. This square root button on my calculator. And 29, close the parentheses. Say 5.385 to the nearest 100th place. 100th place is the second decimal digit. So I need to write down the third one to do the rounding. So the third one. Since this is 5, we don't need more digits. We only look at the digit immediately to the right to round it to this place. Okay, 5.39. This is the approximate value of square root of 29. Now, your exercise problems. Another example, when you find the square root of this number, again, we need to use a calculator. Not much different, just another number, square root 0.000196. So this is the exact number 0.014. So this is not approximate number, this is exact equal to each other. Another set of exercise problems. Now let's look at the next learning objective. Divide monomials with decimal coefficients. First, we learned this formula before, a to the m divided by a to the n. When they have same base, the result of the division will have the same base. What is the exponent? You use the first one minus second one. This division can be also written as fraction format. They are the same thing. So now, apparently this one divided by that is equivalent to 8.2 n to the 6 divided by 2.5 n squared. So basically, we are going to use 8.2 divided by 2.5 to get the coefficient, the number in front of variable. So 8.2 divided by 2.5. We get 3.28. So 3.28. So when you do division, you do subtraction using the first exponent minus the second one. So n to the fourth power. Actually, this is very easy to do in an intuitive way. You don't have to do subtraction, even though subtraction is easy enough. Basically, you do it like simplifying fractions. You have 2 n's on the bottom, like n times n. You have 6 n's multiplied together on the top. Then you cancel this 2, you still have 4 left on the top. You still have 4 left. the smaller one get canceled. That way to look at things is way convenient in the second example. So let's do that. First, negative divided positive is negative. Our final result is negative. Now we just need to do division. 3.85 divided by 0.5. 3.85 divided by 0.5. 7.7. So we get 7.7. Now let's look at variables. We have 5x on the top. That means x times x times x, 5 of those. And 4 on the bottom, 4 cancel, you still get 1 left on the top. And the y totally canceled, you still have z left on the top. That's our final answer. There's nothing left on the bottom. Okay, exercise. Now solve equations using the multiplication principle. Don't worry about this principle. As long as you do it in a logical way, you don't have to know the name of what you do. Okay. First, when we solve the equation, we want to have this variable on one side by itself. How do we get rid of negative 14.2? We do the opposite operations to cancel things. What is the opposite operation of this? This 14.2 and x are connected by multiplication. We want to undo this multiplication by using opposite operation, opposite of multiplication, division. So we divide by this number in front of x, whatever it is. Okay, doesn't matter what it is, because anything divided by itself is 1. That's why we do division. We want to have x, x means 1x. The result is this division between these two numbers. The result is negative for sure. So we get 39.05 divided by 14.2, 2.75. So we solve it. Solve and check. Let's check it this time to see if it's correct. So if we get right answer, then plug it back in here. Negative 14.2 times this number will be equal to 39.05. So let's do that. Negative 14.2 times negative 2.75. We don't need to plug in this negative number, negative signs in the calculator. We already know negative times negative is positive. So let's just multiply the two numbers together. 14.2 times 2.75 equals, certainly that is correct. Okay. Now we get a exercise set for this example 8. Now we have this as application problems. Not problems. Maybe more on the next page, I don't know. So example 9, Laura owes a hospital $1,875.84. She arranges to pay the debt in monthly installments over 1 year, so 12 installments. How much is each monthly payment? So how much she need to pay per month? First of all, basically, we will divide her total debt into 12 equal parts. That's one of the basic meanings of division. Remember that? Division means, say, for example, 10 divided by 5 equals 2. We divide 10 into 5 equal parts. That's how much each part. This time, we divide this whole thing into 5 equal parts. This whole thing into 12 equal parts. We get 1 part. So very easy to understand once we understand the meaning of division. We divide this whole thing into 12 installments. The result is 1 installment. So 1875.84 divided by 12. We get 156.32 per month. That's her schedule, monthly payment. Okay. Now exercise problems, you have two application problems. Now example 10, let's see, let me have a peek if this is the last one or not. Yeah, this is the last example. After this, you have your last exercise problems. Example 10, in these two examples, we use a 3.14 whenever we need to use pi. A, the radius of Earth is about 6,378 kilometers at equator. Find the circumference of Earth at the equator. Equator is like the biggest circle whenever you do a cross section of Earth. So suppose this is a equator, okay? It's a circle. And we need, we are given the radius. Radius from center of circle to the edge, okay, 6,378 kilometers. We need to find the circumference. The circumference of circle is given by this. 2 pi r, if you're given r radius, or the circumference equal to pi times diameter. Either way is okay. Diameter means 2 radius. From here to here, diameter. So these two together is a d. So these two are the same formula, basically. Since we are given radius, we're going to use this formula. So 2 times 3.14, we are told to use 3.14 for the pi, and times the radius, 63. 78. We just multiply these three numbers together, basically. 2 times 3.14 times 6378. Double check, 6378 equals. That's a big number. 40,053.84. It didn't say round to which number. Let's just round it to the whole number, because such a big number, we round up half kilometer doesn't make much difference. So 40,054 kilometers. Don't forget the unit. For any measurement, we need to have unit. Otherwise, yeah, you could misunderstand the result. If you give the number to other people without unit, it could mislead other people. For example, if this another person takes this as a miles instead of kilometer, because you didn't give the unit, the difference is huge. 1 mile equals 1.6 kilometers. So if this is written as a mile, is equivalent to more than 6,000. More than 60,000 kilometers. That's a big difference. Now let's look at B. Find the diameter of an official basketball rim. They mention of official because it's a standard, which has a circumference of approximately 56.52 inches. So this is a basketball, suppose. And we are given the circumference. That means the total length of a circle going through the center of the basketball. And we are looking for the diameter. So the center, we're looking for this length. So first, we need to determine how to do it. So whenever you work with a problem that is a geometry problem, always try to associate the information with a certain formula. This is about circumference of a circle. We have two formulas involve circumference. One is 2 pi r. One is pi d. Which one do we need? We need to use this one because we are asked to find diameter. Certainly you can use this one, but this one you can only find the r radius. After you find that, you have to double it to get diameter, because this whole thing diameter, this part is radius. But Fundamentally, there's no difference. Either one is okay, but this one is just a little bit more convenient because we get D directly. So apparently, circumference is given 56.52 equals 3.14 times D. So when you solve it for D, we do that by dividing by this 3.14 on both sides. So cancelled, we get diameter 56.52 divided by 3.14. 18 even. So that's 18 inches. Diameter of this official basketball is 18 inches diameter. And this is your last set of exercise problem. Let me know any questions posted in the comment area or any suggestions. I really appreciate that. See you guys in the next video.